Welcome to the 6.4 notes, dividing polynomials with long division and synthetic division. We're going to start by looking at dividing just numbers using long division. So we say 296 divided by 7. You can remember the numerator goes on the inside by remembering in and out. So in and out like the hamburger, the top goes in, the bottom goes out. And then we say 7 doesn't go into 2, so we look at how many times does 7 go into 29. 7 goes in 4 times, so we identified 7 going into 29, divided 7 into 29, and then we do 7 times 4, gives us 28, and then we subtract. So there's actually several distinct steps there. We identified 7 going into 29, we divided it, then we multiplied 4 times 7, and then we subtract. We get 1, bring down the 6, and we start again. 7 goes into 16 twice. 2 times 7 is 14. Subtract, and we have 2. 7 doesn't go into 2, so we call this a remainder. So what we can do is we can say 296 divided by 7 is equal to 42 and 2/7. Notice we put the 2 over the 7. We had divided by 7. Our remainder goes over 7. Okay, we also want to recall that we can separate fractions just like we can add fractions with like denominators. If I have a fraction with addition or subtraction in the numerator, I can separate it into multiple fractions as long as the denominator is not 0. And that's what we're going to use in our first type of division, where we have a polynomial divided by a monomial. So in example 1, I have here a polynomial, and I'm dividing it by 5x, which is a monomial, only one term. And what that means is I can divide each term by that denominator. So I can take 10x cubed divided by 5x, subtraction, so we say minus 5x squared divided by 5x, and then plus 20x divided by 5x. We call this term-wise division. I'm dividing each term by 5x. And from here it's simplifying. So 10 divided by 5 is 2. X cubed divided by x is x squared minus 1x plus 4 and no x. So just 4. And so this will be our result. The result from division is called the quotient. Okay, so our result here is called our quotient. Let's look at another example. This one's already set up as division in a fraction form. So what we want to do is we want to divide each term by this denominator. Now you can write it out the way we did up here. I'm going to try doing it without rewriting it. So I'm looking at my first term divided by x squared y, and we can think about this as a 1x squared y. 5 divided by 1 is 5. X to the 5th divided by x squared is x cubed. Y squared divided by y is y, minus 15 x cubed divided by x squared is x, y divided by y, no y, minus 1x squared y divided by 1x squared y is just 1, minus 6x divided by x squared y. Now this time we are going to be left over with some denominators. So I have a 6 in the numerator. X divided by x squared leaves me over x, and then nothing, or 1 divided by y, leaves it over y. And so our quotient this time has a fraction in it, and that's okay. We can have fractions in our quotient as long as the denominator is equal to or smaller than our original denominator. So we just want to make sure that our fraction is completely simplified as much as possible. I'm going to leave the try this for you to do, and we will go over it in class. So go ahead and do the try this, pause the video, and then I'll do example 2. All right, hopefully you've done the try this. In example 2, we're dividing not by a monomial, but this time by a binomial. So I have a polynomial divided by a binomial. Now for this, we need to use long division. Okay, so recall how we did in the first part where we divided just numbers. The numerator goes on the inside by the denominator goes on the outside. So we have x plus 2 goes into 2x squared minus x minus 10. And we're going to use the same steps that we used with numbers. First, we write it as a division statement using long division, and then we identify. And what we're going to identify is our leading term. How many times does x go into 2x squared? Another way to ask this is, what do I have to multiply x by to get 2x squared? So it would be x times 2x gives me 2x squared. So that was identifying and then dividing. We divided x into 2x squared. And now we multiply 2x squared times my whole divisor, x plus 2. So 2x squared times x, or 2x times x is 2x squared. 2x times 2 is plus 4x. And then we subtract. And I'm not subtracting just the first term, but I'm subtracting the whole polynomial that we just multiplied. So when I'm subtracting, you can think about it as distributing that negative, because it's 2x squared minus 2x squared, which gives me 0. And then negative x minus 4x. So negative 1 minus 4 is negative 5x. And then, just like with numbers, we bring down our minus 10. So let's see that process again. We start over at the beginning. Identify, x goes into negative 5x how many times? Well, x times negative 5 gives me negative 5x, so that was dividing. Next, we multiply. 5 times x, or negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. And then we subtract, and we're subtracting the whole thing. So I'm going to show you, what does it look like when I distribute this negative? Well, if I distribute the negative 1, it becomes a positive 1, and I've distributed the negative. So every sign changes. Every sign changes. Now I'm doing addition. So negative 5x plus 5x is 0. Negative 10 plus 10 is 0. Okay, so you don't have to distribute the negative, but I do think it's easier to see the operations when you distribute the negative. And now we can see that there is no remainder because 0 plus 0 is 0. And so our quotient is 2x minus 5. Our solution to this division problem is 2x minus 5. Let's look at another example using long division. Part B, here because I'm not dividing by a monomial, that tells me that I need to use long division here. So in and out, 3x minus 5 goes into 6x squared minus 19x plus 12. And then I identify 3x into 6x squared. Dividing, 3x times what gives me 6x squared? 2x. Multiply, 2x times 3x squared. 2x times 3x is 6x squared. 2x times negative 5 is negative 10x. And then subtract. And when I subtract, I'm going to distribute the negative, meaning I change every sign. And now I can add 6x squared minus 6x squared is 0. Negative 19x plus 10x is minus 9x. And bring down my plus 12. Starting over, identify 3x into negative 9x. Divide, how many times does it go in? 3 times negative 3 gives me the negative 9x. Negative 3 times 3x is negative 9x. Negative 3 times negative 5 is plus 15. Then subtract. Distributing my negative, I change all of my signs. Negative 9x plus 9x is 0. 12 minus 15 is negative 3. And because 3x does not go into negative 3, I know that that is a remainder. So how do I write this quotient? Well, I have the 2x minus 3, and I have my remainder, which always goes over my divisor, my denominator. So we get plus negative 3 divided by 3x minus 5. All right, looking at the next page at example 3, we want to, again, use long division because our denominator is not a monomial. So we're going to set up our long division, x plus 4 into 7x cubed plus 16x squared plus 2x minus 1. And then we identify our first terms, divide. So what do I have to multiply x by? I multiply by 7x squared, then multiply it. 7x squared times x is 7x cubed. 7 times 4 is plus 28x squared. And then subtract. I'm going to distribute my negative. 7x cubed minus 7x cubed is 0. 16x squared minus 28x squared gives me negative 22. Nope, negative 12. Negative 12x squared. Bring down my plus 2x. And then identify. X goes into negative 12x squared how many times? Minus 12x. Multiply. Minus 12x squared minus 48x. Then subtract. I'm going to distribute my negative. Every sign changes. Negative 12x squared plus 12x squared is 0. 2x plus 48x is plus 50x. Bring down minus 1. And then start over. X goes into 50x plus 50 times. Multiply that. 50x plus 50 times 4 is 200. And subtract. Distribute my negative. 50x minus 50x is 0. Negative 1 minus 200 is negative 201. X does not go into negative 201. There's no x for it to go into. So this is my remainder. So how do we write our quotient? 7x squared minus 12x plus 50 plus negative 201 divided by our denominator x plus 4. And that is our quotient. Now you might say, well, plus a negative is just subtraction. So yes, you can also write this 7x squared minus 12x plus 50 minus 201 divided by x plus 4. But we have to be careful that the entire numerator is negative when we do that. So if there's multiple terms, you have to factor out the negative. So be careful when you do that. Both of these are equivalent. Okay, again, go ahead and pause the video, do the try this, and then we'll look at example 4 together. In example 4, we're looking at, our denominator is not a monomial. However, notice we have a degree missing. This goes from a degree 2 to a degree 0. So we need to put what's called a placeholder here. And the way we put a placeholder is we do 0x. So we're not changing the value of the expression at all, but we are putting them so that they go in descending order without any missing degrees. And we have to do that both for the numerator and denominator. So if we look at our numerator here, we have degree 4, degree 3, degree 1. So that means in here I have to add 0x squared to hold the place of our degree 2. So let's go ahead and write our long division statement. X squared plus 0x minus 1 into 3x to the 4th plus 2x cubed plus 0x squared minus 8x plus 6. From here, the division process is the same as what we've seen in our last few examples. We are going to identify, divide, multiply, and subtract. So we identify, divide, this goes in 3x squared times, multiply, so distributing to every part of my denominator, 3x to the 4th plus 3 times 0 is 0, x cubed minus 3x squared, and subtract, distributing that subtraction, changing every sign, and then we add 0. 2 minus 0 is plus 2, x cubed, 0 plus 3 plus 3x squared, bring down minus 8x. And then we repeat. Identify, divide, x squared goes into 2x cubed plus 2x, multiply, 2x cubed, 2 times 0 is 0x squared, 2 times negative 1 minus 2x, subtract, distribute. 2 minus 2 is 0. 3 minus 0 is plus 3x squared. Negative 8 plus 2 is minus 6x. Bring down plus 6. And we start again. X squared into 3x squared goes in 3 times. So we multiply out. 3x squared. 3 times 0 is 0x. 3 times negative 1, minus 3. And subtract. Distribute my negative. 3 minus 3 is 0. Negative 6 minus 0 is negative 6x. 6 plus 3 is 9. Now x squared cannot go into 6x, and therefore this is our remainder. So let's write our quotient. We have 3x squared plus 2x plus 3 plus our remainder, negative 6x plus 9, divided by our divisor, or our denominator, x squared minus 1. Now I have a fraction here, which means that I need to simplify. So we can write this as 3x squared plus 2x plus 3 plus, I can factor negative 6x plus 9, our GCF of negative 3, 2x plus 3, and our denominator factors into x plus 1 times x minus 1 because it's a difference of squares. So I can write this as negative 3 times 2x plus 3 divided by x plus 1 times x minus 1. That doesn't simplify any further, so I know that I'm done. And that whole thing altogether is our quotient. Go ahead and do the try this, and together we'll look at the next page, so go ahead and pause the video now. On the last page, we talked about how do we know when we're done dividing? How can we tell that we've reached the remainder? So think about this and we'll go over the answer in class. Our next topic that we're going to discuss is called synthetic division. Synthetic division is a way of dividing by certain polynomials instead of long division. And we want to only use synthetic division when we're dividing by a polynomial with the form x minus c as our denominator. Meaning I can't divide by something with an x squared or an x cubed, but just x minus a number, and that number can be negative, so it could also be x plus c. And the way we divide this is we look at comparing our method of long division, and we look at it without the variables. And we can see that because we have all of our variables in descending order, we can remove them and they still hold the same place values. And so our answer has descending order with no missing variables because of our placeholders. And so we can look at division specifically by things like x minus c, so x plus 4 or x minus 3, and then we can add in the variables to our quotient. So we can write the variables back in. Let's look at an example of how we can do this. So in example 5, we're looking at dividing this polynomial here by x minus 3. And our first step is to say, what would our x value have to be to make this 0? So if x minus 3 was 0, what would x be? So plus 3, x would have to be 3. And that's what tells us the number that goes in this top corner here. So since 3 would give us a value of 0 here, we're dividing synthetically by a value of 3. And then we put our divisor, the numerator, in descending order with just the coefficients. So here 2, our x squared has a coefficient of negative 1. Our degree 1 term has a coefficient of negative 13. And then our degree 0, or our constant term, has a coefficient of 1. And then we follow this pattern. The first number drops down and stays itself. And then we multiply by 3 times 3. So we're multiplying by our number that we're dividing by. 2 times 3 is 6. And then we add. Negative 1 plus 6 is 5. And then we do it again. Multiply by 3 5 times 3 is 15. And add negative 13 plus 15 is 2. Multiply by 3 is 6. And add is 7. Okay, so what are the steps we did? We first rewrite, drop, multiply, add. And then we multiply and add until we've reached the end. Now this last number is our remainder, and it will always be our remainder. Sometimes that last number will be 0, and that's what tells us that we have no remainder. And then we have our quotient underneath this line. So we have 2 plus 5 plus 2 plus 7 over something, because remember our remainder always goes over our quotient. Now how do we know what our x's are? Well, I started with a degree 3 and I divided, so the degree decreases by 1. So this becomes x squared, x, no x, divided by x minus 3. So we started with a degree 3. Our quotient is degree 2. So we end up with our quotient 2x squared plus 5x plus 2 plus 7 over x minus 3. And that is our final answer. Okay, the steps are written here in the box, but we're going to look at another example. Notice this answer is the same as what we had from long division, and if we use long division, just ignoring the variables, and that's where synthetic division comes from. Let's look at example 6. In example 6, we want to divide this polynomial by x plus 2. This satisfies the form that we need in order to use synthetic division. So we need to find out what would the x value be to make this 0. So for x plus 2 to equal 0, x has to be negative 2. That's what we're dividing by here, negative 2. And then we put our coefficients from our numerator. So x to the 4th, x to the 3rd, x squared. And then we're missing our x to the 1st, so we put 0, and our linear term, 34. And then we follow the pattern for synthetic division. The 1 comes down and stays itself, times our divisor, negative 2, times negative 2. 1 times negative 2 is negative 2. And then we add them to get negative 4, times negative 2 is 8. Negative 11 plus 8 is negative 3. Negative 2 is 6. 0 plus 6 is 6. Times negative 2 is negative 12. 34 minus 12 is 22, and that is our remainder. So then we write our quotient. This was degree 4, so our answer is degree 3. X cubed minus 4x squared minus 3x plus 6 plus our remainder, which is 22, divided by x plus 2. Again, we always want to check if our remainder can be simplified. 22 divided by x plus 2 cannot be simplified, and so that's our final answer. Okay, thinking about what our requirements are for using synthetic division, I want you to try the concept check and we'll go over the answer in class. On the next page, to try this, I want you following the method of the last 2 examples. Think about what value are we dividing by? What are my coefficients? Follow the process of synthetic division for part A. And then part B, I'm going to have you draw your own diagram for synthetic division. So following the example from part A, draw that same shape to do synthetic division on part B. And again, we'll go over the answers in class. So pause the video now, and when we resume, we'll do example 7 together. If you finish the try this, we're moving on to example 7. For example 7, our first part is just finding p of 2. Now remember, p of 2, not p times 2, means that we're substituting 2 for everywhere that there was an x. So we're substituting 2 for x. To find p of 2, we find everywhere that there was an x, replace it with a 2, and follow the order of operations. So we have 2 times 2 cubed minus 4 times 2 squared plus 5. Order of operations is we do the exponents first. 2 cubed is 2 times 2 times 2, which is 8, minus 4 times 2 squared is 4, plus 5. Next, we do multiplication and division. 2 times 8 is 16. Negative 4 times 4 is minus 16, plus 5. Now with addition and subtraction, 16 minus 16 is 0, so our solution is 5. For part B, we're going to do something similar, but instead of finding p of 2, we want to find p of x divided by x minus 2. X minus 2 satisfies our requirements for synthetic division, so we want to say x minus 2 equals 0, then x equals 2. So for synthetic division, we're setting up our divisor to be 2. We need our coefficients for p of x. So 2 is our x cubed, negative 4 is our x squared. We're missing our x to the first, so it goes 0. 5 is our constant, my division line, and remainder box. Bring down 2. 2 times 2 is 4. Negative 4 plus 4 is 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. 5 plus 0 is 5. So this gives me the quotient of 2x to the, this was a degree 3, so it is now degree 2, plus 5 over x minus 2. That's our quotient. What we're looking for, though, is the remainder. So our remainder is 5. Now we want our answer from part A was 5. Our answer from part B is 5. And what this demonstrates to us is that to find the remainder of a polynomial, it's equivalent to substituting in that value for x. So these are equal to each other. And that is actually a theorem. It's called the remainder theorem. And the remainder theorem says that if a polynomial p of x is divided by x minus c, the remainder is p of c. So what we did is we demonstrated that with the number 2, where c equals 2. For example 8, we're going to demonstrate this again using synthetic division. So we want p of 4, that means our c value is 4, and that means we're dividing by a value of 4. We put our coefficients, x to the 6th, x to the 5th, x to the 4th. We're missing x cubed, so it's 0. X squared, x to the 1st, and don't forget the 0 for your constant term. Using synthetic division, we bring down the 4. 4 times 4 is 16. Negative 25 plus 16 is negative 9. Times 4 is negative 36. Add those together to negative 1. Times 4 is negative 4. Add those together is negative 4. Times 4 is negative 16. 17 minus 16 is 1. Times 4 and add them. Times 4 and add them. So our remainder is 16, which means that p of 4 equals 16. And if you'd like, you can double check that using your calculator by substituting every x with a 4. Go ahead and write a conclusion statement, and we'll go over the try this and the concept checks in class tomorrow.